This one, the x-intercept 9, 0, the y-intercept 0, 9. This one, the x-intercept 21, 0, the y-intercept 0, 7. So I'm leaving that work to you, all right, to find each of those. This is your x-intercept, y-intercept, x-intercept, y-intercept. I'm going to need to go at least 21, right? Both in the x and y direction. So let me count by fives. 5, 10, 15, 20. So that's 20. 5, 10, 15, 20. That's 20. All right, now some colors. Let's do blue for this one. 7, 0. So here's 5, right? 7, would you agree, is here? 7, 0. And then 0, 21 up here. And then I draw a straight line through those. Solid, right? Seem like I'm working fast? I feel like I'm working fast here. That good for the blue one? All right, red one. 9, 9. So here's 10, 9's right before it. 5, 10, here's right before it. So I'll label these 9, 0 and 0, 9. Oh, I forgot to shade. But I can trust that you could test that 0, 0 on that blue one. Which side of the blue line are you going to shade? To the left or to the right? Left. So on that blue one, it is going to be to the left. And then the red one is going to be like kind of below it, I guess, or to the left. And then let's do the other one in green. And that's going to be 21, 0, which is out here, and 0, 7, which is about here. I draw a solid line through those. Ah, shit. Man, and that's really hard to see what's going on there, isn't it? That's really tough to see. This is an issue. This is going to be a little bit of a problem. But it's okay. We're going to be able to deal with this. We shade below. Below, okay? The problem is my picture is not very accurate because I'm just up here drawing dashes. So it's hard to see where these points are. Would you agree with that? Okay, so let me show you how we're going to resolve that. We do know these points, right? We do know those points. It's just really a question of what's going on in here, right? What's happening in there? So we have a couple of options. We could draw a bigger picture so we can be more accurate. We can use graph paper. But what I'm going to do is find the intersections of these. So let's just find these intersections. Where does the blue hit the red? So I have to set this up, don't I? 3x plus y equals 21 and x plus y equals 9. That's what I have to do? I'm trying to figure out where the blue and the red hit.
You can times the bottom by 3.
Bottom by negative 3. Negative 3. Negative 3 here. The new system, 3x plus y is 21. Negative 3x minus 3y is equal to negative 27. And add straight down.
Wait, it's not plus y anymore, is it?
Plus what?
Negative 3 plus y. Or,
Negative 3.
'cause you're multiplying
Negative 3x Negative 3y.
Yeah, gotcha.
Yeah.
Yeah.
And then negative 27. So add down, what do you get? Negative 2y equals negative 6. Divide both sides by negative 2. Y is
Y equals
3, positive 3. Now take that back in and solve for x. So we can do it right here, right? Plug in 3 right here. So 6. X is 6. So there's a 0.63. One, two, three, 4, 5, 6. 6, 3. I'm kind of zooming in on that right there so you can see it. This is where the blue one hit the red one. Right? That's where that blue hit the red at the 0.63. Okay, how about where does the red hit the green? So I have to do x plus y equals 9 and x plus 3y equals 21. So what would you do here to solve this system?
The x already cancel out.
Not yet. Make one of them negative. So multiply maybe the top one by negative 1 and become negative x minus y equals negative 9.
Plus or what? I thought it was per. Oh no,
What happens when you add straight down here? 2y is 12, so y is 6. If y is 6, what's x? X is 3. So if I come over here and I go 3, 6, right here, 3, 6, that's where which one hits which one? The green and the red. So the green one was coming through kind of like this. Right? You can tell from the pitch of the line, right? The green one was like this. So do we really need to find this point? No. It doesn't appear we do. Could we, though? I mean, we could by just taking what? These two and setting them equal to each other? Like, or doing a system? I'm not going to, all right? We have the points of interest. There's a point right here. There's 2 points in here that we need to check. There were 2 in there, weren't there? There were 2 in there. This is our region right here. We've got to check. How many points total are we checking?
5.
5 points total. This one, this one, this one, this one, and this one. So let's list out the 5 points we're going to test. We're going to test 0, 0. We're going to test 0, this one right here, 0, 7. This one down here, 7, 0. And then those 2 points that we just got there that were 3, 6 and 6, 3. And we're testing those into this. So for x and for y, for x, y, x, y, x, y, x, y. So what does p equal if we plug in 0, 0? 0. What does p equal if we plug in 0, 7? 0 for x and 7 for y. 70, right? What do we get if we plug in 7 for x and 0 for y? 140. Okay, what do we get when we plug in 3 for x and 6 for y? So 20 times 3 is 60, plus 6 times 10, which is 60, I get 120, don't I? What happens if I plug in 6 for x and 3 for y? So 6 times 20, 120, plus 3 times 10, which is 30, which gives me 150. So what is the maximum value of p? The maximum value is 150. At the point, where does it happen? 6, 3. Okay, I'm out of time. We obviously don't have enough time to do a word problem. But I would say, like I did on the review, that you should look at page 280, number 41, part A. And that's going to be a word problem like we did in class. And I know y'all had some trouble interpreting those words and turning them into this thing, right? So do your best. Have a good weekend. Study, be prepared. It's the first test, so you want to start off strong here. Yes? Do I have what? I don't know how many. I think 10's too long. So maybe 2? No, I'm kidding. I don't know.